everyone, myself Henasha, Assistant Professor at LG Institutes of Engineering and Technology. So today we are going to discuss few more topics of Laplace transform. So let us begin with the first topic, that is inverse Laplace transform. So if Laplace of f of t is equals to f of s, then f of t is called inverse Laplace transform of f of s and is denoted by f of t is equals to Laplace inverse of f of s, where this L inverse is called inverse Laplace transform operator. Okay, so now let us discuss few inverse Laplace transforms, right? So we all know that Laplace of 1 is what? 1 upon s. So if I take this L on this side, then Laplace inverse of 1 upon s will be what? 1. Then we know that Laplace of t raised to n is what? N factorial upon s raised to n plus 1, or it can be written as gamma n plus 1 upon s raised to n plus 1. Right? So again, if you take L on this side, then Laplace inverse of, suppose I write 1 upon s raised to n. So we have to subtract 1 from everywhere, right? So it will be what? T raised to n minus 1 upon n minus 1 factorial, or it will be 1 upon gamma n t raised to n minus 1, right? Similarly, we can write the formula of Laplace inverse of 1 upon s minus a. It will be e raised to at. 1 upon s plus a, it will be e raised to minus at. Now, whenever you see this s square and a square, so s square and a square, whenever you see, then we know it will come sine or cos. So whenever you see constant in the numerator, right, what you see constant in the numerator, sine will come. And whenever you see s in the numerator, cos will come, you can see. And whenever there is minus, right, here s square minus a square, then sine hat means hyperbolic functions will come sine or cos. And lastly, Laplace inverse of 1 will be equals to delta t, and this is our direct delta function. So now let us start with the examples. So we have to find Laplace inverse of 1 upon s raised to half. So here you can see n is 1 by 2, right? So we all know the formula of Laplace inverse of 1 upon s raised to n. It is t raised to n minus 1 upon gamma n. So here answer will be t raised to minus half. Put n as half. So t raised to minus half upon gamma half. We all know the value of gamma half. It will be what? Square root pi. So your final answer is 1 upon root pi t, right? You can bring this in the denominator. Okay. So now let us go to our next topic, that is first shifting theorem. This is similar to the theorem we have discussed before, just we have changed the notations, right? So if Laplace inverse of f of s is equals to f of t, then Laplace inverse of s minus a will be what? E raised to at f of t. So in this, what you have to do, whenever you see s minus a in your question, you have to remove a and put e raised to at and find the Laplace inverse of f of s, that will be what? F of t. Right? Now let us discuss the second shifting theorem, right? So if Laplace inverse of f of s is equals to f of t, then Laplace inverse of e raised to minus as f of s will be f of t minus a ut minus a. So whenever you see inverse and e, then you have to apply second shifting theorem, right? So let us understand this using our examples. So here we have to find inverse Laplace transform of this. So we have to find Laplace inverse of s plus 2 upon s square minus 4s plus 13, right? So in this, first we have to set the last term. So we all know the formula of last term. It is middle term square upon 4 into first term, right? Here our middle term is minus 4. So answer will be 16 upon 4 into 1, right? So the last term will be 4. So let us write that Laplace inverse of s plus 2 upon s square minus 4s. Now our last term is 4, right? So we have written this. Now in all we want 13. So here what we have to add? 9, right? So 4 plus 9, that is 30. So now let us modify this. So it will be equal to Laplace inverse of s plus 2 upon s minus 2 whole square plus 3 square. This is the formula of a minus b whole square. So we have written it as s minus 2 whole square plus 3 square. Now whenever we have s minus 2 in the denominator, I want s minus 2 in the numerator also. So we will have modification in this term. So we can write it as Laplace inverse of, write the denominator as it is. Now we want s minus 2, so write it. Now in all it is s plus 2. So what we have to add? Plus 4. So you can see we have obtained s plus 2. Now we will split this in two parts, right? So we will have Laplace inverse of s minus 2 upon s minus 2 whole square plus 3 square plus take this 4 outside because it is constant. So Laplace inverse of 1 upon s minus 2 whole square plus 3 square, right? Now whenever you see s minus a, right? What we have to apply? First shifting theorem. That is, you have to write e raised to at f of t. So here let us write that. Firstly take out this minus 2. So it will be e raised to 2t. Now you can see what is remaining. Laplace inverse of s upon s square plus 3 square. Whenever you see s in the numerator, what will come? Cos. So we will write cos, and here e is what? 3. So cos 3t plus 4 times. Now here also take out plus minus 2. So it will come e raised to 2t, right? Now if we have 3 over here, so we want 3 also in the numerator. So multiply and divide by 3. So we will have 4 upon 3 e raised to 2t. Now it is a constant term in the numerator. So whenever there is a, we will have sine, right? So we will write sine 3t. So this is our final answer obtained using first shifting theorem, right? So now let us discuss one more example. We have to find inverse Laplace transform of the given function. So here you can see E, right? So we will apply second shifting theorem, right? So firstly let us find Laplace inverse of 1 upon s square plus 8s plus 25. So again here also we need to find our last term using our formula what? Middle term square upon 4 into first term. So here our middle term is 8. 8 square will be 64 upon 4 into 1. So answer will be what? 60. So let us write that Laplace inverse of 1 upon s square plus 8s plus 16. Now total we want 25. So what will come? Plus 9. 16 plus 9, that is 25. So now let us write whole square. So 1 upon s plus 4 whole square plus 3 square. Right? Now here you can see in the numerator we have 1. But here a is 3. So multiply and divide by 3. Firstly apply first shifting because we can see here s minus a term, right? That is s minus minus 4. Okay. So what we will write? 1 upon 3. Then next, first remove this. So it will be e raised to minus 40. Now we have 3. That is a in the numerator. So we will have sine 3t. And this is our f of t. Now let us bring this e raised to minus 3s. So e raised to minus 3s s square plus 8s plus 25. So whenever we have e in Laplace inverse, we have to apply second shifting theorem, and the formula is f of t minus a ut minus a, right? But here the value of a from this is what? 3, right? So answer will be f of t minus 3 ut minus 3, fine. So now just we have to replace in this t by t minus 3. So our final answer will be 1 upon 3 e raised to minus 4 t minus 3 sine 3 into t minus 3 ut minus 3. Right? You just have to find the Laplace inverse and just replace t by t minus a and multiply by ut minus 3. So this example we have solved using our second shifting theorem. Okay. So now let us go to our next topic, that is method of partial fraction. So whenever you cannot separate such type of things, we have to use partial fraction. So whenever we are given linear and distinct factors such as s minus a, s minus b in the denominator, if we want to separate this, we will write a upon s minus a plus b upon s minus b and find the values of this capital A and B. Similarly, if we are given linear but repeated factors such as s minus a whole raised to n. So if it is repeated 2 times, then we will write a upon s minus a plus b upon s minus a whole square. Suppose if it is repeated 3 times, then we will write plus c upon s minus a whole cube. And suppose if it is repeated n times, then we will write lastly an upon s minus a whole raised to n. Similarly, suppose if the factors are quadratic and distinct, that is, if we have quadratic factors such as s square plus es plus b into s square plus cs plus b, and I want to separate this, then we will write as plus b upon the first factor plus cs plus d upon the second factor, right? And lastly, if the quadratic factors are repeated, then what we will do? First write as plus b upon one time, then plus cs plus d upon its square. It is similar to our case 2, right? So this is the method of partial fraction. So now let us solve examples. So we have to find inverse Laplace transform of this. Here you can see the factors are linear factors, right? So what we will write, 1 upon s plus root 2 upon s minus root 3 is equals to a upon, we will write first factor, that is s plus root 2 plus b upon s minus root 3, because the given factors are linear. So we will apply our case 1. Now let us take the LCM. So what will remain? 1 is equals to a into s minus root 3 plus b into s plus root 2. Right, now we want to find this a and b. So what we will take the values of s as? Firstly, from this we can take s as minus root 2. Consider this as 0, so s will be minus root 2. And from this we will get s as root 3. So now let us put these two values of s in our this equation, right? So let us start putting. So if you put minus root 2, this will remain 1. A into minus root 2 minus root 3. Suppose if you put over here, it will go to 0. So finally our value of A is minus 1 upon root 2 plus root 3. So this is our value of A. Fine. Now let us put this root 3 in this equation. So 1 is equals to, this will go to 0, b times root 3 plus root 2. So b is what? Root 2 plus 1 upon root 2 plus root 3. Right? Now let us put these two values in our this equation. So 1 upon s plus root 2 into s minus root 3 is equals to, what is our answer of A? It is minus 1 upon root 2 plus root 3, and this will remain as it is, that is 1 upon s plus root 2 plus 1 upon root 3 plus root 2 into 1 upon s minus root 3. Now let us apply our Laplace inverse. So Laplace inverse of 1 upon s plus root 2 into s minus root 3 will be, from both of these I will take out this common, that is 1 upon root 2 plus root 3. So inside what will remain? Minus Laplace inverse of 1 upon s plus root 2 plus Laplace inverse of 1 upon s minus root 3. Fine. So in this I have taken this common and applied Laplace inverse on these two. So let us write now just the inverse formulas. So whenever we have s plus or s minus, we know e will come. So answer will be minus e raised to minus root 2t plus, here it will be e raised to plus root 3t. Right? So this is our final answer. Okay. Now let us go to the next example. We have to find Laplace inverse of this given equation, right? So here we are given 4s plus 5 upon s plus 2 into s minus 1 whole square. So now let us again apply the method of partial fractions to separate this. So firstly what we will write, a upon s plus 2, right? Because this is a linear factor. Now this is repeated 2 times. So what we will write, b upon s minus 1 plus c upon s minus 1 whole square. Right? Now let us take the LCM. So what will remain? 4s plus 5 is equals to a into s minus 1 whole square plus b into s minus 1 s plus 2 plus c into s plus 2. Now here we have to find three variables, that is a, b and c, and we have only two values of s, that is s is equals to minus 2 and s is equals to 1, right? So firstly let us put these two values. So if I put s is equals to minus 2, here it will become minus 8 plus 5, so minus 3 is equals to, here this will become a into, if I put minus 2 right here, it will be minus 3 whole square. Fine. This will go to 0. This will also go to 0. So the value of a will be what? Minus 1 upon 3. Right. So the value of a is minus 1 upon 3. Now if I put s is equals to 1 in this, so here I will have 9 is equal to, this will go to 0. This also will go to 0. Here I will have 1 plus 2. So 3c. So C is equals to 3. Now only what is remaining? We have to find the value of B. So in order to find the value of B, what we will do? We will compare the coefficients of S square first. So here we can see, if we open the bracket, it will be S square minus 2S plus 1, right? So we will have A only. From this also you can see we will have what? Only B. So if I separate this bracket, I will have s square plus s minus 2, right? So you can see the coefficient of s square will be b, and here there is no s square, so we will have a plus b, and from here there is no s square, so we will have coefficient as 0. Just put the value of a as minus 1 upon 3, right? So minus 1 upon 3 plus b is equals to 0. So b is 1 upon 3. So what we have done right here, we have just compared the coefficient of s square on both the side, right? Coefficient of s square. Done. So now let us put 1, 2 and 3 value in our this equation, right? And also multiply by Laplace inverse. So Laplace inverse of 4s plus 5 upon s plus 2 into s minus 1 whole square is equals to Laplace inverse of, we have a upon s plus 2, but our value of a is what? Minus 1 upon 3. So minus 1 upon 3, 1 upon s plus 2. Plus now our value of b is plus 1 upon 3, right? Laplace inverse, and what was the function? 1 upon s minus 1. And lastly put the value of c, that is 3. So Laplace inverse of, lastly what we will have? 1 upon s minus 1 whole square. Now we just have to find the Laplace inverse of these three terms. Okay, so firstly write minus 1 upon 3. Okay, so whenever we have s plus 2 in the denominator, we know what will come? E raised to minus 2t. Right? Plus 1 upon 3. Now here what will come? S minus a we have. So answer will be e raised to t, because the value of a is 1, plus 3 times. Now here we have to apply first shifting theorem, because we have s minus 1 whole square. So first remove this minus 1. So what will come? E raised to t, right? Now what is remaining? 1 upon s square, and we know Laplace inverse of 1 upon s raised to n, that is t raised to n minus 1 upon n minus 1 factorial whenever n belongs to n. So here we have 1 upon s square. So put n as 2. So we will have only t. So this is our final answer of the given example. Okay. Now let us move on to our last example, that is we have to find inverse Laplace transform of 5s plus 3 upon s minus 1 into s square plus 2s plus 5. Okay. So let us start solving it. So 5s plus 3 upon s minus 1 into s square plus 2s plus 5 is given. So here this is a linear factor. So what we will write? A upon s minus 1. This is our case 1. Now this is our quadratic factor. So this is case 3 of our method of partial fraction. So what we have to write? Bs plus c upon s square plus 2s plus 5. So from this you can see, whenever we have linear factor, constant will come. Whenever we have quadratic factor in the numerator, what will come? linear factor, right? You have to decrease one power and write. So now let us take the LCM. So finally what will remain? 5s plus 3 is equals to a into s square plus 2s plus 5 plus bs plus c times s minus 1. So now let us simplify this by opening the brackets. So finally 5s plus 3 is equals to as square plus 2as plus 5a plus bs square, right, plus bs plus cs minus c. So this is what is remaining after opening the bracket. Here minus will come, okay. Now we will just separate s square, s and the constant terms and write the coefficient only. So here the coefficients will be a plus b. Here we have s, so write the coefficient of s and they are 2a minus b plus c, and lastly the constants are what? 5a minus c, and here we have 5s plus 3. Now let us start comparing the coefficients. So a plus b will be equals to 0. Next compare the coefficient of s. So 2a minus b plus c is equals to 5, and lastly write the constants. So 5a minus c is equals to 3. Fine. So from this I can write that b is equals to what? Minus a. So if I put over here, what I will get? 3a plus c is equals to 5, and here I have 5a minus c is equals to 3, right? So our 8a is equals to 8. So finally our value of a is what? 1. So our value of b will be what? Minus 1. And again let us put the value of a in this. So 5 minus c is equals to 3. So c will be finally equals to what? 2. Done. So now let us put all these three values in this equation, right? So Laplace inverse of 5s plus 3 upon s minus 1 into s square plus 2s plus 5 is equals to Laplace inverse of, our value of a is 1, so put 1 over here. So we will have Laplace inverse of 1 upon s minus 1 plus, put the value of b and c, they are minus 1 and 2, so plus Laplace inverse of minus s plus 2 upon s square plus 2s plus 5, right? Now what we will do, firstly write the Laplace inverse of this. It is very simple, it will be e raised to t. Now we will firstly take out minus common, so Laplace inverse of what we will have? S minus 2 upon s square plus 2s plus 5. Done. Now let us set this last term. So last term formula is middle term whole square plus 4 into first term. Here middle term is 2, so 2 square is 4 upon 4 into 1, right? So last term is what? 1. So e raised to t minus Laplace inverse of s minus 2 upon s square plus 2s plus 1. Now I want total 5, so we have to write plus 4. So we will have e raised to t minus Laplace inverse of s minus 2 upon s plus 1 whole square plus 2 square, right? This is 2 square. Now set s plus 1 in the numerator as we have done a sum before also. So e raised to t minus Laplace inverse of, write s plus 1 firstly. So what we have to subtract in order to find minus 2, we have to subtract by minus 3. Denominator will remain as it is. Now just separate the bracket. So finally we will have e raised to t minus Laplace inverse of s plus 1 upon s plus 1 whole square plus 2 square. Now this minus minus plus, so we will have plus 3 Laplace inverse of 1 upon s plus 1 whole square plus 2 square, right? Now whatever the constant is over here, we want here also, so we will multiply and divide by 2, right? And write finally the Laplace inverse. So we will have e raised to t as it is minus, here we have s plus 1, so we will apply first shifting theorem, right? So take out this plus 1, so we will have e raised to minus t. Now we have Laplace inverse of s upon s square plus 2 square. In the numerator, s means what? We have to write cos 2t. Done. And finally here it will come plus 3 by 2. Remove this plus 1, so we have to write e raised to minus t. Now we have constant in the numerator, so what we will write? Sine 2t. So this is a very important example, and the final answer is this. Okay, so I hope you have understood throughout the session. Thank you for watching.